Okay, this is the mark scheme for the C3 paper. So the question 1, part A, the range is fx greater than 0. Part B, so the inverse function works out to be f inverse of x equal to 3 plus ln x over 2, and the domain is the same as the range for f, so which is x greater than 0. Part C, so f of ln4 first, that works out to be 8e to the minus 3, and you plug that into g of f of ln4, which is basically 3 of 8e to the minus 3 minus 1, which works out to be 24e to the minus 3 minus 1. And f inverse of g of x equals to 5, so that's basically the same as 3 plus ln of 3x minus 1 over 2 equals to 5, and when you sort it out, you get x equals to 2e squared plus 1 over 3. Question 2. Part A, so y equals cosec x cubed, dy dx is minus 3x squared cosec x cubed cot x cubed. Part B, y equals x minus 3e to the minus 2, so it'll be just minus 3x to the minus 4e to the minus 2. Remember, e to the minus 2 is just a number, it's not a function. Question C, you just use quotient rule, and you get 2 minus 3 sine x over 3 minus 2 sine x whole squared. Okay, and question 3. So what I did is I factorized the denominator, which works out to be 3x minus 2x minus 2, and then I divided using long division, and then it doesn't cancel any further, so it becomes x squared plus 2x plus 4 over 3x minus 2. Part 2 is quite easy, you just factorize it again, so you get e to the x minus 6, e to the x minus 2, so e to the x equal to 6, so it's x equal to 2, and x equal to ln 6, so x equal to ln 2. Question 4, so fx equals r cos x, so you got to kind of just sketch the y equals cos x graph on the side between minus pi over 2 and pi over 2, and then you can see the arc cos is just the same thing on the y-axis as shown. It should be symmetrical like a nice arc. Okay. Part B, so 3 of f of x minus 2 minus pi equal to 0, so you take the pi to the other side, divide by 3, so you get arc cos x minus 2 equals to pi over 3. So x minus 2 equals to cos pi over 3, which is half, and then 2 plus half is 5 over 2. Okay. And question 5. So you differentiate this graph and you get 2e to the 2x cos 3x minus 3 to the 2x sin 3x, and you factorize e to 2x out. So when dy dx equals to 0, it's only going to be the bracket equal to 0, and you get tan 3x equal to 2/3. The only one thing here, the domain should be 0 to pi, not pi over 6 or whatever I wrote. So you get x equal to 0.1960. Remember to write to the correct decimals, guys. Even though it's 196, it should be 4 decimals. Question 2, so x equal to sine squared 3y, so dx dy equals to 6 sine 3y cos 3y, which is same as 3 sine 6y. So dy dx is 1 over 3 sine 6y, and that is 1/3 cosec 6y, so you get p equals to 1/3, q equals to 6. Question 6 is quite easy. So at the top, sine 2x becomes 2 sine x cos x. At the bottom, cos 2x plus 1 equals to sine x. So 2 cos squared x, and it cancels nicely. You can see here I kind of wrote this down so you can figure out what this cos 2x plus 1 is. Part B, so using that previous one, so the left hand side becomes just 5 over 2 sine x, and then it becomes a quadratic. You use quadratic formula, and then you get the answers, minus 0.300 or minus 2.842. 3 decimal places required, guys. So okay. Question 7, so f of 0.9 is less than 0, f of 1 is greater than 0, so there's a sign change, so therefore there's a root. When x equals 0, f of 0 is minus 2, and f dash of x is that. You just differentiate the original function, and then you basically put the 0 in, you get the gradient as 3 over 2, and then you get the tangent, which is 2y minus 3x plus 4 equal to 0. This is quite simple. You just use the trigonometry, b cos x cos c plus b sin x sin c equals to cos x plus 2 sin x, and then you get b equal to root 5 and c equals to 1.11. And once you got that, you can just write the equation in terms of that, and then make it equal to 0, and then you get these answers here. Okay, so that's the paper, guys. So good luck for tomorrow, and I will write a C4 paper very shortly.